Welcome to A2 Graphing Equations. Alright, so we now have all the background knowledge to start graphing lines. During this part of the standard, we will be creating and analyzing graphs of linear functions. Let's start with slope-intercept form equations. And of course, we're going to go over slope-intercept form, standard form, and point-slope form. So, in a slope-intercept form equation, which to jog your memory is y equals mx plus b, we know that the m represents our slope and the b represents our y-intercept. And we know that a y-intercept is where our line will cross the y-axis. All right, pause the video if you need more time. I'm going to scroll down. All right, well, let's get right to it. So let's plot our y-intercept first. And we are dealing with this equation above, y equals 3x minus 4. Okay? So what is my y-intercept? Well, we just said my y-intercept is b, and since this is in slope-intercept form, y equals mx plus b, my m is 3 and my b is negative 4. So I'm going to plot my y-intercept at negative 4. Okay? From this point, we can plot the slope by using the rise over run method. In this example, our rise would be 3, and because this is a whole number, our run would be 1, because 3 is the same thing as 3 divided by 1. So we will go up 3 units, and to the right, 1, just unit. Okay, so from this point, I'll go up 1, 2, 3. I'll put my pen right there, and I'll go over 1. That's where I'll draw a point. Now I'll repeat that process. I'll go 1, 2, 3, and I'll go over 1. And heck, I could do that one more time if I wanted to. I'll go up 1, 2, 3, and over 1. And now I just draw a nice straight line connecting all of these points. Okay? So look at that. We've graphed our first line. So now let's talk about point-slope form equations. Pause the video if you need more time. Okay, so remember how to put a point-slope form equation into a slope-intercept form equation? Well, I do, and I certainly hope you do as well. All we do is distribute the slope and then solve for y. Okay, so once we have it in slope-intercept form, we can use the process we just used above. So let's try this one. We have y minus 4 equals 2 over 3x, 2/3 times x minus 3. So I'll distribute my slope. So I'm left with y minus 4 equals 2 over 3x minus 2. And if you're confused about 2 over 3 times negative 3, just come and get me during class. Okay, so what we'll do now, we want to get y by itself, so we'll add 4 on this side, and we'll add 4 on this side. Okay, once we do that, our 4's cancel. So we're left with y equals 2/3 x, and then negative 2 plus 4 is a positive 2. Okay, so now we have a slope-intercept form equation. Y equals mx plus b, where my m is 2/3 and my b is 2. So just like last time, I'll plot my y-intercept, which I know is at 2. So I'll go up 1, 2. I'll make my first point. From there, my slope is 2/3. So my rise is 2 and my run is 3. So I'll go up 2 and over 1, 2, 3. Okay, and I'm going to run out of graph space this way, but if I wanted to graph more points, I could also go in this direction as well. So I could go down 2 and to the left, 1, 2, 3. That'll still get me my line. So I'll connect these points. And there we have it, our linear function. Okay. So last but not least, we can also graph linear equations in standard form. We can do this by solving for y, putting the equation in slope-intercept form, which we know how to graph. Or we can use the Jake's method, just like we did previously in the standard when we were trying to find slope. So we're going to look at both ways using the same example. So pause the video if you need more time. So using slope-intercept form. So to get this in slope-intercept form, I need to solve for y. So I'll subtract 3x from both sides. So 3x minus 3x cancels. So I'm left with 4y equals negative 3x minus 4. And to get y by itself, I need to divide everything by 4. So 4's cancel here, so I'm left with y equals negative 3 over 4x minus 1. So now I have an equation in slope-intercept form, and I know how to graph these already. So my b, or my y-intercept, is negative 1. So I'll make my first point at negative 1. And I know my slope, or my rise over run, is negative 3 over 4. So my rise is negative 3. So instead of going up 3, I'm going to go down 3. So go down 1, 2, 3. I'm going to keep my pen right there. And my run is 4. So I'm still going to go to the right 4. 1, 2, 3, 4. So just like last example, I'm going to run out of graph space down in this section. So I'm going to go up this way. So I could also go up 1, 2, 3, and to the left 1, 2, 3, 4. So now I can make a line, hopefully a straight one, connecting all of these points. And I strongly encourage you to use a ruler when you are doing this, so your lines are as accurate as possible. Okay. So there, we've done it. So let's take a look at the Jake's method now. So to use the Jake's method, I must find my slope and y-intercept, just like I did with my slope-intercept and point-slope form equations. So I know from earlier in the standard that I can find the slope by solving for negative a over b in a standard form equation. Okay? I can solve for my y-intercept by either plugging in 0 for x and solving for y, or by solving for c over b. Okay, so just to make things clear, negative a over b and c over b are not just random fractions we're pulling out of the air. They come from converting a standard form equation into slope-intercept form by solving for y. So if we had our standard form equation, ax plus by equals c, and we solved for y, we would have our equation without numbers. We would have a, b, and c instead. We would have this in slope-intercept form, and we would realize that our slope would be negative a over b, and our y-intercept would be c over b. So let me label here. We have the same example, a, b, and c. So my slope, which equals negative a over b, equals negative a, which is 3, over b, which is 4. Okay, and my y-intercept is c over b. So my c is negative 4. And my b is positive 4. So negative 4 divided by 4 is negative 1. So let me circle these. Okay, so my y-intercept is at negative 1, so I can go down to negative 1, plot my point. And my slope is negative 3 over 4. So instead of going up 3, I'll go down 3. 1, 2, 3. Keep my pen there. And I'm going to the right 4. 1, 2, 3, 4. And because I'll run out of graph space down here, I can go up 1, 2, 3, and to the left 1, 2, 3, 4. Now from this point, I can draw a nice straight line. And I see that I have the exact same line as I did using the slope-intercept form method as I do the Jakes method. So it's all a matter of preference. So at this time, I would watch the example video for A2 graphing lines.